Okay, so day one here, we're going to start off with some of the main things that you'll see in midterm one. Okay, so very first type of question you're going to notice they're going to have you simplify a rational expression. Okay, rational means fraction, right? Like a fraction type of expression. So this is called a rational expression. Now, when you look at these things, you should not be saying, oh, I'm going to cancel this out right there. You can't do that. Okay? You cannot do that. I know they look identical, but remember there's plus signs and minus signs that all sticks it together. The only way you can get rid of things like that is if you find matching pieces that are not being added and subtracted with each other. So what we're going to do is we're going to try to rewrite this in a factored form. What can I factor from the top? X squared plus 6x. What do they have in common? Just an x, right? So I'll take out an x, and the remaining will be an x plus 6, right? Because if you take an x out of x squared, an x is left over. If you take an x out of 6x, just the 6 is left over. Now the bottom part, that's a trinomial. That's an x method, okay? So let's do this kind of small here. My a times c, that's negative 18. And my b value is a 3. What two numbers multiply to negative 18 and add up to 3? A 6 and a 3, positive 6, a negative 3, right? So 6 minus 3 is 3. 6 times negative 3 is negative 18, so we're good. That means that this factors into x plus 6, x minus 3. That's the bottom part. So I'm going to write it down. X plus 6, x minus 3. Can I cancel anything here? The x plus 6's because they match. Okay, identical. So all that's left is x over x minus 3. Okay, so x over x minus 3. Now again, do not feel the urge to cancel these out. Don't do that. I mean, if it was x on the top and x on the outside, like a times x, then sure. But this is x minus 3. It's stuck with that subtraction. You can't just chop it off. Okay? You can't just do that. So maybe if up here there was another x right there, then sure, I can cancel those out if there was two x's like that. Because that's multiplication. You can do that with multiplication. But with addition, you can't. Or subtraction, you can't. You got to find matching pieces. So this would be my answer for this problem right here. Okay, just factoring. I'm really hoping that factoring is no longer something you hate to do. I hope so. We've been doing it for so long that I think it should be second nature now, but maybe not. But I'm hoping it is. All right, so that was a simplified problem. Nothing was really happening. We were just kind of simplifying a couple things. Now this is a division of fractions. Now remember, we don't divide fractions, we multiply by reciprocals, right? So right now we're going to rewrite this and then start working on it. So if you look at the left side fraction on the top, is there anything that I can factor from n minus 4? No, right? I mean, people always say, well, you can take a 1 out, but a 1 doesn't do anything, so there's no reason to do that. So I'm just going to write it n minus 4. You'll notice I put in a parenthesis because I figure there's going to be things that are going to match eventually, so I'm just going to put it in a parenthesis. All right, what can I take out of the bottom part, the bottom left? An n, and what else? A 7. I can take out a 7n. And what's left? An n minus 4. All right, perfect. So notice those two things are going to cancel, n minus 4, n minus 4. But let's not do anything yet. I'm going to put times. And now I got to flip it. So the 3n really ends up on the bottom. The n minus 2 really ends up on top. Okay? But let's see, 3n, can I factor anything out of 3n? No, right? So remember, don't write it on top. That goes on the bottom because you're flipping the fraction. The n minus 2, is there anything I can get rid of from n minus 2? No, so then that's going to be n minus 2. All right, I can cancel, we said, right? I can get rid of n minus 4, n minus 4. So it's equals. Now, before I just multiply this out, if you guys don't mind, I'm just going to write it like this, just so you can see the result of the cancellation, okay? That's what happens once we cancel. So now to multiply, you just multiply straight across. So 1 times n minus 2 is just n minus 2. On the bottom, 7n times 3n is 21n squared. And that's it. That's your answer. Now, after this problem is done, I wrote you a little FYI, okay? I said a compound fraction. So you're probably going to see a compound fraction, or else I wouldn't be talking about it, right? A compound fraction is written like that. So see how it's a fraction divided by a fraction, like a really big fraction, right? You can rewrite it just straight across. N minus 2 over 3n divided by n plus 4 over n squared minus 2n. So you can just rewrite it. And then from there, remember, you're supposed to change it to multiplication, flip the second fraction, and start working on it, okay? So I'm just showing you right here to go from this step to this step, okay? You can rewrite it like that, and then make it times, right? We can kind of continue and say like this would be n minus 2 over 3n times n squared minus 2n over n plus 4. And then you can start factoring things out if you want, okay? But if you see a big old fraction, now it doesn't have to look this complicated. It could just be like a 2/3 divided by a 4/5. Like it could be something easy, just a little fraction numbers, no letters. But make sure you rewrite it, okay, and then flip the second fraction, make it multiplication. So notice we're not going to do this problem because we just did a problem like that, okay? But I'm just showing you the process of if you see this, you must do the following, okay? So, like I said, chances are you're going to see that at least once. Okay? A problem just like that, similar. You just have to flip it, rewrite it and flip it, and then you should be good. Then the rest of it gets done like we did this one. Right? So, all right. This is a direct variation problem. Okay? By the way, today I'm going to talk to the teachers from my period not my period 3, my math 3 classes that we all share, and I'm going to ask them about notes. Can you use a page of notes, 2 pages of notes for your midterm? Last time we let you, I don't know if they're going to let you this time. Okay, we're going to vote on it and let's see what happens. Chances are 1 page is probably going to be okay, but I don't know. We'll see. Okay, so I'll let you know tomorrow. So if not tomorrow, maybe what I'll do is I'll send out an announcement today, kind of through your Google Classroom, telling you yes or no. Because maybe you might want to take your time today to start writing like a little cheat sheet for yourself if you're able to do it. So, all right. If y varies directly as x, and y is 15 when x is 12, find y when x is 32. Now, you're going to see these problems like this. You're going to see them in word problems like story problems sometimes. It doesn't really matter whether they're writing a story behind it or what. They'll tell you whether it's direct or indirect. Okay, they'll say directly or indirectly, or inversely, sorry. I think they say inversely. And if they say whichever words, then you have to write specific equations out first. So for us, when I see the word directly, okay, so this piece right here, that tells me, oops, I'm sorry. I'm trying to think how I used to write it. So it would look like this. The way I learned it when I was in high school, my teacher gave it to us like this. Sometimes that's better. Sometimes the red one's better. It just kind of depends. So your books like it the way it is in red. So That's what I want to stick with. Okay? So if something varies directly, then that's the formula you're going to do. Notice I wrote it twice, right? And if you remember, the reason why I would write it twice is because the first time my goal is to solve for k. The second time my goal is to solve for whatever letter they want. Okay? First equation, you solve for k. Second equation, you solve for whatever they want. So let's look at this piece here. It says if y varies directly as x, and y is 15 when x is 12. So 15 over 12. Well, 15 over 12 I can reduce by 3, so it's 5 over 4. At least I can do that. Okay? Then you're going to get this k value, and you're going to plug it into that equation. Okay? But let's keep reading. Find y when x is 32. So find y when x is 32, and k is 5 over 4. Now remember, you are allowed to use calculators. So what I'm going to do is I'm going to multiply 32 over to the fraction. 5/4 times 32. Okay, so you punch that into your calculator if you like, or you can do it in your head. Y is equal to 40. Okay, the reason why I know it's 40 is I don't know how your teachers taught this to you guys back in middle school, but the way I learned it, my teacher said you multiply 5 times 32 first, and then you divide by 4. You know, and I used to do that all the time. Then eventually I started getting older. I'm like, why am I multiplying first and getting this huge number and then dividing it by 4? Why don't I divide by 4 first? Then that number will get smaller. Then I'll multiply by 5. So 32 divided by 4, that's 8. And 8 times 5 is 40. That's easier than 5 times 32. Right? 5 times 32, what is that? 160, then 160 divided by 4. Right? Those are big numbers. So I'd rather deal with the small numbers. So I always divide first. Whenever I multiply a number times a fraction, I divide first, then I multiply second. So it's just a nice little trick to keep your numbers as small as possible. I mean, you do whatever you want. Again, you have a calculator. You don't have to really worry about it. But if you don't want to do it with the calculator, I recommend division first, multiply second. Okay? Are we okay with this one? So direct variation, okay? And that leads us to this one, which is a word problem. So I'll give you a little bit of time. I'll pause the video. But notice this one is inversely, right? Inversely. So let me pause it and then we'll get to it. All right, so for this one right here, it is a word problem with inverse variation. We know it's inverse variation because they literally say inversely. So we're going to write the formula for it. Let me make sure I have my right color here. So xy equals k. xy equals k. Remember, you always write it twice because the first time you're solving for k, the second time you're solving for either your x or your y value. So it says the width of a rectangle varies inversely to its length. If the width is 4 and the length is 8, find the width when the length is, when the length is 18, find the width when the length is 8. I'm like, why are they repeating? But no, one was 18. So I have to basically give one of those things, width or length, an x or a y value. It doesn't really matter. So I'm just going to go with, we'll say width is x, and we'll say length is y. Okay? So I'm just going to assign it like that. All right. So if the width is 4 when the length is 18, so x is 4 when y is 18. So 4 times 18. That's equal to k. Well, 4 times 18 is 72. So there's my k value. They call it the constant of proportionality, right? So this is my k value. So what I'm going to do now is I'm going to plug it in over there. But I'm also going to look at the last part of the problem. It says find the width, which is x, when the length, y, is 8. So 8x equals 72. Right? My y value is 8. My x value is what I'm solving for. And I found out that k was 72. So all I got to do is divide by 8. and x is equal to 9. That's the width that they want. Okay? Notice it is a word problem, but it's not like, oh my gosh, a word problem, right? Like, it's the same problem that we did from before. It's just, it has more stuff to it, right? But if you kind of strip away all the extra, it's basically the same problem. All right. So, any questions on any of the first four, out of curiosity? All right. Subtract and simplify. Subtract and simplify. Now, the reason why I'm doing a subtraction, let me just double check real quick. Hold on. Yeah. The reason why I'm doing a subtraction is because the addition problems aren't tricky. You just add everything. The way it looks, you keep the signs the same, you don't change anything. It just kind of adds together. Subtraction is always tricky because this negative in the middle has to distribute. When you have a plus sign and you distribute a plus, it never changes any signs. It's all the same. Okay? It never changes anything. But a minus sign in the middle changes everything on top. So that's why I decided let's do a subtraction problem, not an addition. Because an addition one, even if you messed up and you didn't change the signs, that's what's supposed to happen. With a subtraction one, if you mess up and you don't change the signs, you're going to get it wrong. Okay? So I'd rather do the ones that can probably create some issues, right? So this one would create issues. All right, so we have a 2x plus 10 minus x plus, over x squared plus 6x plus 5 minus an x plus 5. Okay, now let's subtract the tops. So I'm going to put this right here, 2x plus 10 minus x minus 5 over, the denominator does not change, okay? Denominator does not change. All right, so now let's combine the top. I have 2x minus x, that's going to be an x. 10 minus 5 is a positive 5 over x squared plus 6x plus 5. The question is, can I further simplify this? Can I factor the bottom and it becomes an x plus 5 down there? I mean, let's check it out. Yeah, it is, right? Let's factor the bottom part. 8 times c, that's 5. Your b value is a 6. So it would be a plus 1 and a plus 5. So this would be an x plus 1, x plus 5. So x plus 5, not factorable, divided by x plus 1, x plus 5. Let me move this up here. Can I cancel? Yeah, I got 2x plus 5s, right? So I can actually get rid of this. So all that's left is 1 over x plus 1. So just because you subtracted doesn't mean you're done. Okay? Check. Is there more that you can do on the top? Is there more you can do on the bottom? Right? Anything that can be factored, do it. If you cancel stuff out, great. If you don't, well, at least it's simplified. Okay? Are we okay with that one? Number 5? Because this is where they start to get kind of weird. Number 6. Solving for x. So we got 6 and 7, and then we're done. Okay? So this is solving rational expressions, okay, or solving rational equations, I guess you could say. Does anybody remember what we used to do with these to try to fix them? Because I hate fractions. We would multiply by the denominator. Well, the LCM or LCD, I guess you call it, least common denominator, the least common multiple. So remember we used to say, okay, I have a 3, an x, and an x. So I don't want to multiply by 3x squared, but they at least have, so if you look at all the bottom parts, okay, all the denominators, within all three, they at least have 1 3, right? And they at least have 1x. Okay? Now, what's the highest power you would see on the 3? Well, there's only a 3 to the first, so it's just 3. What's the highest power you see on the x's and the denominators? A 1, right? This is my least common denominator, which means I get to multiply that whole equation by 3x. Now again, let me repeat the process. You can write down all of your denominators, okay, 3x and x. Then you write down everything that they have in common, okay, at their least. So they at least have a 3, they at least have an x. Now I know there's 2 x's, but you don't want to list both of them. Just list the thing they have in common. So they at least have an x there. Then you ask yourself, what are the highest powers on those things you picked? So the highest power on 3 is a 1. The highest power on x, well, it's just a 1. X to the first, x to the first. So it would be just a 1, okay? So I'm going to multiply everything by 3x. So 3x, I don't know if you guys remember doing this, but I would always rewrite it. I told you that it would normally look really long because of the fact that I have to rewrite all of it with a 3x in there. So notice I'm multiplying every term by 3x. And now I get to cancel stuff out. So look at the first fraction, 3x times 5/3. What can I cancel out from there? A 3. Yeah, this 3 with that 3. What can I cancel out in the second part? 3x times 2 over x. An x. What can I cancel out on the last part on the other side? An x as well. Remember, the reason why we multiply by this 3x is because I want to get rid of my fractions. Look what happens once I do that. So this is now 5x minus 6 equals 24. No more fractions. They're all gone. Now I can just solve this. This is a math 8, math 7 type of problem, right? 2-step problem. Let's add 6 to both sides. That gives me 5x equal to 30. And then if I divide both sides by 5, I get x equal to 6. So remember, when you're doing these little problems that have fractions plus fractions, or maybe fractions minus fractions equal to another fraction, you're going to try to figure out what can I multiply by in order to get rid of all my fractions. Now, if you don't like the way this is right here, if you don't like the way it is, you could just take everything in the denominator and multiply by it. Okay? You can, if I multiplied 3x and x together, this would be 3x squared. You could multiply everything by 3x squared. That's fine. Okay? It's just you're multiplying by more things, which means you're going to have to simplify more things eventually. Okay? So there's nothing wrong with multiplying by just, I always tell people the lazy way to do it is just to get your denominators and multiply them out. Don't worry about it. 3x squared. But sometimes that causes a little bit more of a mess. So then you have to kind of fix it. So I do recommend just doing 3x. And that gives you the easiest possible result to solve. Which, as you can see, is not a hard one to do. All right, so here we go. Last one. Now these are long. Okay, and you do have these on your quiz, probably just one, because they do take a long time. Okay, at the most 2, but maybe the second one will be a lot easier. And yeah, these can be a bit of a pain. So, you know how in the last problem we said, okay, what's the least common denominator, right? Like what do they have in common so I can multiply everything by it, right? And then from there I can solve. I'm going to do the same thing, okay? But this is going to look a little more messy because I have tons of stuff everywhere. And eventually we'll like factor things out and all that stuff. But for now, I'm going to try to factor out the bottoms only. Now, if you notice, x minus 3 on the very far right side, you cannot factor that denominator on the bottom. But on the left side, x squared minus x minus 6, I can factor that. So let me do that really quick over here on the side. So the x squared minus x minus 6, this becomes negative 6 and a negative 1. So you're going to use a minus 3 and a plus 2. So this will be x minus 3, x plus 2. So if I may, I'm going to rewrite this. It's going to take us a little bit of time, but I'm going to rewrite this thing, okay? So as I rewrite it, I'm going to look at the top parts and ask myself, can I factor those things? Okay? So look at the x minus 4. Can I factor anything from x minus 4? X minus 4 is just x minus 4, right? So x minus 4. All right. The bottom part will be x minus 3, x plus 2, plus. Now this next fraction is also going to have x minus 3, x plus 2. Okay? But now I got to ask myself about the top part. What can I factor out of the top part that you can see like maybe immediately? A 2. So let me do that. 2x squared plus 2x minus 3. Okay? Now, I might still be able to factor that part, x squared plus 2x minus 3. I got to check, but let me just keep writing stuff. I cannot factor x minus 2, and I already told you I cannot factor x minus 3. And now, all right, so once we got this part written out, if you're listening to this from first period, it got stuck for them, okay? Excuse me. So it got stuck at the x minus 3 part, so I was supposed to just write it. But then we do the LCD portion, which is this piece right here. Notice all the denominators are represented on the left side of it. X minus 3, x plus 2, x minus 3, x plus 2, and x minus 3. We look for what they all had in common, at least one of each, right? So x minus 3 to the first, because there's no second power on any of them. And then the x plus 2 is the next one. And even though the third one doesn't have an x plus 2, it's okay, right? As long as it shows up once, and we just got to write that down to its highest power, which is power of 1. So that is this part right here is my LCD, okay? So here's the part that kind of sucks. The way I do it, well, I don't do it like this anymore, but the way I learned it is to get x minus 3, x plus 2, and multiply it times everything, but that means I got to write it out. So this is going to take me a while, all right? So here we go. Let's write out that multiplication. So I'll use a green here. So x minus 3, x plus 2 times x minus 4 over x minus 3, x plus 2 plus x minus 3, x plus 2 times 2x squared plus 4x minus 6 over, I'm going to probably have to shift this down, don't worry, I can just drag and drop, equals, so give me a second, let me just drag this down. All right, and then x minus 3, x plus 2 times x minus 2, x minus 3. I wrote them small because sometimes if you write it normal size, it carries over all the way. So just trying to hopefully plan for not having to do that. Notice on the first fraction on the very far left, I can cancel everything out, right? I can cancel all of this stuff out. X minus 3, x plus 2, it's all gone. In the middle fraction, same thing, x minus 3, x plus 2, that's all gone. On the last fraction, only x minus 3. But that means all my fractions are gone. So let me rewrite what I have. I have an x minus 4 plus 2x squared plus 4x minus 6 equal to, now guys, this part right here, this piece right here, this is a difference of two squares. When you multiply it, it becomes x squared minus 4. Okay, just FOIL it. X times x is x squared. X times negative 2 is negative 2x. And then 2 times x is positive 2x, so those cancel. And then 2 times negative 2 is a negative 4. So you get x squared minus 4. Now let's combine everything. Let's move everything to the left side eventually, but first let's combine on the left. I have an x plus a 4x. That's going to become 5x. I have a negative 4 minus a 6. Those are like terms, okay? So that's going to become a minus 10. So let me fix that really quick. 2x squared plus 5x minus 10 equals x squared minus 4. Now let's add 4 to both sides. I know I could have subtracted x squared. It doesn't really matter. 2x squared plus 5x. This is where I messed up. I put minus 14. This should have been minus 6. Okay? But I mean, notice right there, I wrote minus 14. Negative 10 plus 4, I put minus 14. After I did all that hard work, I mess up on that. Like, come on, right? Like, that's when you get really mad at yourself, when you're like, man, is that. I did everything. I did the hard part just fine, and I messed up on addition, right? So, all right, let's subtract x squared. This is why I tell you guys, just take your time, try not to rush, because when you do that, you will make just careless errors. We're almost done. Almost done. What do I do now? I got to factor one more time, okay? And that's going to give me my two factors that I can set equal to 0 and solve, okay? So, all right, x method. A times c is negative 6, b is a positive 5, okay? So what two numbers do I use? Negative 1, positive 6, is that right? That's negative 6, and that's going to give me a positive 5, yep. So there you go. So this will become x minus 1, x plus 6 equals 0. So set each one equal to 0 and solve. This is the easy part now, right? So here we go. And I'll add 1 to both sides. That gives me x equals to 1. I'll subtract 6 on both sides. That gives me x equal to negative 6. Here are my two answers. You can either write them like this, or like, oops, I'm sorry, or like this. Either one is fine.